Now, what I've given you in front of you here is this giant polynomial, which by now you should know is a set of monomials here, all together separated by addition and subtraction, which create a polynomial. You should also know by now what a like term is, because we're going to need that for our first step. A like term is when you have variables, or a group of variables, or a variable that are exactly the same thing. With the same exponent, they're basically like identical variables or groups of variables. Our first step is to find them. So the best way to find like terms, and the easiest way, is to highlight which terms are like terms. Some people prefer boxing them or giving them a different circle, but we're going to highlight them. And we're going to start first with our x squared y here. And then you're going to look at the polynomial and you're going to find if there is another x squared y anywhere in this polynomial. And there is. It's right here. Next, we're going to do the next term, which is 2xy. And you're going to tell me, or you're going to find, if you see another xy anywhere in this polynomial, and you will, it is here. And last but not least, we have our lonely here 3y. And that's fine. It's just going to stay that way because there's nothing that we can add or subtract it to. The next thing that we're going to do is we are going to add and subtract the like terms we just highlighted. The like terms. So now, you need to pretend as though you cannot see these ones when we are focusing just on these ones. Okay? You also need to pay attention to the operations that are in front of the terms, if are any. So right now what we have is x squared y plus 4x squared y. Now, if you want, you can rewrite this. You don't have to, but you can. And for the sake of this being the first time, maybe, I'm going to rewrite it like this. X squared y plus 4x squared y. Just so that they're side by side. I'm then going to rewrite the other like terms following it. So in green, we had plus 2xy minus xy. And then in red, we have our lonely plus 3y. And now we are going to do the operation that is being asked. In front of this here, you can imagine that there's a little 1 here. And when we add these two together, 1 set of apples plus 4 set of apples, we have 5 sets of these apples. And over here, and again you can imagine that there's a 1 here, 2 sets of apples minus 1 set of apple, you're left with 1 set of apple. And it's positive, and there's a plus here, so we're just going to bring it back down. And then lone here is just plus 3y. And then we're going to look at it again, and then we're going to ask ourselves, are we done? Have we simplified everything? Is there no more like terms that we can add together? No, there is not. And so this here is called our simplified polynomial. So notice how we had this huge polynomial, and with the help of finding like terms and adding and subtracting them, we have this. Now just as a side note, I want you to know that in a polynomial there can be 3 like terms, there can be 4 of the same like term, there can be 5 of the same like term, it's not always 2 of the same like term. As long as you pay attention to the operations that are happening in front, and you do what it is that the operation asks you to. I'm going to talk to you about a simple word problem. You have $500 in your bank account, and you spend $25 on food, and you spend $30 on a t-shirt. When we were doing BEMDAS or order of operations, you would be asked to maybe translate this into a mathematical sentence. So say you started with $500. Well, you spent $25 on food plus $30 on the t-shirt. Now ask yourselves this. Are you only taking away $25? Or are you also taking away the $30? Well, you're also taking away the $30. So another way that we could rewrite what I just wrote is something like $500 that I started with minus 25 minus 30. And in the end, it will all come to the same answer. But what I want you to look at is what happened to the minus sign. Well, the minus sign kind of got applied to the stuff on the inside. What the minus side outside the bracket does is, we'll say, just to make things simple for you, the minus sign changes the sign of the terms inside the bracket. And what I mean by changes the sign is either positive or negative. So if your 25 was a negative, it would then become a positive. If your 25 was a positive, it would become a negative, and vice versa. So I'll show you an example now using algebra. So here is a polynomial again, and you'll notice that there are 4 monomials that make up my polynomial, right? So you have this one, this one, this one, and this one. And the first thing that we could do is we could find our like terms. However, because we have a bracket with a negative here, what we're actually going to do is we're going to do what we call distribute the minus sign. And instead of writing the minus sign, I'm going to be mathematical about it, and I'm going to call it a negative sign. But I'm sure you understand what I'm talking about when I say that. So bringing this in, it's going to change the signs of everything that's already inside the bracket. So this is already a positive, and this is a positive. So now instead, I'm going to rewrite the 3xy plus 2x minus 3xy minus 2x. Now, we're going to do the second step, which was the first step of our first slide. Find like terms. Again, using a handy-dandy highlighter, I have a 3xy, and I also have an xy here. I have a 2x, but I also have a 2x here. So what I'm going to do, which again you don't have to do, you can do this in your head, is I'm going to regroup the colors. 3xy minus 3xy, because that's what I have, plus 2x minus 2x. That's what everything says here. And then 3, I'm going to add or subtract my like terms. So I have 3 groups of apples minus 3 groups of apples. Well, just so happens that I have 0. And then I have 2 apples minus 2 apples, which is also 0, and it just so happens that the answer for this one is 0, and that's okay. That is okay. Now for my last slide, I wanted to make it a little bit more complicated, but we're still incorporating like terms. We're still incorporating adding and subtracting them, but we're also incorporating the infamous negative sign outside of a bracket. So that will be our first step, step 1. Distribute negative inside bracket. So now I'm just going to rewrite the polynomial for x plus 3x squared y, and I'm going to distribute this negative to every term inside. So I'm going to get a minus x cubed y. I'm going to get plus 4 minus x squared y. So do you see how that happened? How I went from a positive to a negative to a positive, and a positive to a negative. Step 2, find like terms. Again, using a nice highlighter. First, we're going to start with the 4x cubed y, or x to the 3, x to the power of 3. Do you see an x to the power of 3 y anywhere in this? Well, I do. I see one here. And then I have 3x squared y. Do I have any x squared y's anywhere here? I do, over here. And I have this lonely number 4. And that's fine. Now, for the sake of teaching this to you and for you to see it, I'm going to rewrite it. 4x cubed y minus x cubed y. And then in purple, plus 3x squared y minus x squared y. And finally in green, plus 4. So answering it, I'm not going to write out step 3. You should know what step 3 is. We're going to answer it. If I have 4 groups of apples minus 1 group of apple, we're going to have 3 leftover groups of apples. Plus, if we have 3 groups of apples minus 1 group of apple, we're going to have 2 groups of apples. And this lonely 4. Then we ask ourselves, is there anything else that we can do? Is it simplified as much as we can simplify it? And the answer is yes, because these two are not like terms, right? Because one has a 3 and the other one has a 2. So they're not like terms. And our 4 doesn't even have any variables, so we cannot group it with anything because it's not identical to anything else in our polynomial. And that is how we simplify polynomials, in addition to distributing the negative inside the brackets.